Okay, well, welcome everybody to this meeting of the virtual CICS user group. I'm Trevor Eddles, I'm CEO of iTech Ed Limited. We're a mainframe consultancy analysis and technical authoring organisation. We're responsible for the content on the virtual CICS website, and we produce the newsletter. And the website can be found at virtualcics.hostbridge.com. Okay, let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation, and today our guest presenter is Russ Teubner. He's CEO and co-founder of HostBridge, and his presentation is called Getting and Using CICS Integration Analytics. And a copy of the slides from this presentation will be on the website later today. And if you missed our previous meetings, you can download copies of those presentations from our website too. And you can listen again to the whole presentation. There's a link on the resources page of the user group website. So that's virtualcics.hostbridge.com/resources.htm. Following Russ's presentation and any questions you have for him, we'll move on to the latest CICS news, the latest CICS related articles. Feedback requests is there to remind me to ask you all for your feedback about this virtual meeting. And then I'll give you the dates and times for the next virtual meetings. So that's the plan. I'm anticipating that will last for somewhere between 3/4 of an hour and an hour. Anyway, as I said, today's presentation is from Russ Teubner. Russ is CEO and co-founder of HostBridge, a provider of CICS integration, orchestration, modernization and analytics software and services. He's conducted pioneering work in integrating IBM mainframes and applications with other systems and networks. He's been a contributing author to various technical publications, and he's the co-author of US patent number 6981257 pertaining to XML enablement of CICS applications, and he's got other patents pending. His strategic business partnership with IBM spans decades, and he enjoys a long-standing relationship with the IBM CICS lab in Hursley, home of CICS development. So Russ, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control over to you. So let me do that now.
Okay. Good. Trevor, am I coming through okay?
Yes, that's all good. Okay,
great. Well, Trevor, thank you for that introduction. I appreciate it very much. I'd note two things. One, it's a pleasure to serve as the host and kind of the sponsor of the CICS Virtual Users Group. So thank you very much for giving us the privilege of kind of creating the technological infrastructure for you to conduct this and create a home for CICS users to get together periodically and discuss relevant topics. Secondly, thank you for the invitation to actually make this presentation. We've been doing a lot of work in this particular area that we've started to call integration analytics. We'll try to explain what that word means, particularly in the context for those of us who are CICS users, and kind of analyze and look at and present what exactly what problem we're trying to solve here. With that, also, as we get toward the end of the presentation, this is a small group. Zoom handles interaction tremendously well. If you have any questions, whether I can answer them right now or get back with you, feel free to do that. I do have some cool HostBridge coffee cups that I use every day. If anyone is in need of one, the price is very reasonable. It's just a question. So anyway, Thank you all very much. I'm going to go off camera now, save a little bandwidth, and I will share my PowerPoint presentation. Okay. Trevor, can you confirm that the slides are coming through correctly?
Yes, they are.
Okay, great. I'm going to keep PowerPoint in this particular mode, this display mode, simply because I have a ginormous monitor on my desk, and sharing the entire monitor will cause everything to shrink on your laptops or your monitors. But what we're going to do is talk about, as Trevor said, this idea of CICS Integration Analytics and what exactly we mean by that. And to be honest, this is what I'm reviewing here is some work that we started doing with customers only about 2 years ago, when we had been kind of working on a product, a new offering from HostBridge, dealing with helping people understand what their, hang on 1 second, I'm going to stop the video, save a little bandwidth there, okay. What was really going on under the covers of CICS. And so it was really the beginning of a journey. I don't need to tell you who I am. Trevor gave me a lovely introduction, so we'll continue. Just a bit about HostBridge, in case you only have a cursory degree of familiarity with us. We focus on developing software products and offering expertise to our customers to make CICS applications available as callable services via APIs. We may be wrong, I may be wrong, but I am not in doubt that many good and valuable CICS applications have been retired prematurely, or have even met an untimely death, because the way they are integrated to or with from outside the mainframe is suboptimal in some way. Either it is not resilient or it does not perform well. We are often brought into an organization just about the time that they've decided there's no way to integrate with these CICS apps, and they're about to throw the baby out with the bathwater. We go in and seek to help organizations realize that no, there's a ton of flexibility with respect to how you can integrate with CICS applications across APIs and do so in a resilient and performant way. We're most known for technology that runs under the covers of CICS that lets us integrate with CICS terminal-oriented applications with absolutely no changes and with absolutely no screen scraping. In other words, the binding relationship between in the integration to the application has no reference to rows and columns or screen formats. We focus on using JavaScript, a state-of-the-art approach toward implementing these integrations. We've also designed it such that it's very complementary with other IBM products such as ZOS Connect EE, and it is 100% zip enabled, the code that we run on the mainframe. Let me try to define what we mean by integration analytics. And so I kind of drew a diagram here that is pretty generic. Kind of on the left-hand side, we have all the stuff that goes on in a hybrid environment. We've got a cloud operation. We've got lots of app servers running in there. We have customers with mobile devices, internal users. And we're going to talk about this a little bit more. Now we have a growing category of technology out there called RPA, or robotic process automation platforms. All of those can find themselves driving workload into the mainframe, running transactions under CICS. Now, there are lots of great tools to help us focus and learn what's going on in the circle on the right. with just focused on the mainframe and just focus on CICS. I can go to SysView and I can see how many times a transaction is run, or how much CPU time is consuming, or what's going on inside of DB2. I've got good microscopes to be able to look inside just that circle. There are also pretty good microscopes to be able, and tools to look inside the circle on the left. What's really going on under the covers of kind of all this network interaction. The problem is when those two worlds meet, how can we really understand how they work together? Or as I sometimes say, how the dominoes fall. In other words, when a customer approves a transaction or requests a bit of work, maybe it's dealing with a financial transaction or an insurance policy, what really happens? What are all the steps that really occur, and what are the transaction workload volumes that are really running under the covers of CICS and on the mainframe? It's connecting those dots that is our mission with this particular product and service offering. And again, for lack of a better word, we've chosen to call it integration analytics, generating analytics to help us understand how all the componentry on the left are integrating with your CICS applications. Now, obviously a key phrase that comes up whenever we talk about this is this notion of end-to-end transaction tracking. We want to be able to, if possible, go all the way and stitch together the pathway and all of the cause-effect relationships from even a mobile device all the way to the CICS programs, transaction, or multiple transactions that are run as a result of that end user interaction. We want to be able to see that and understand it with enough precision to be able to know how the distributed world is driving the mainframe and why. And we'll look at some screenshots in a minute of what we're able to mine from this data. Now, I don't want to presume that everyone understands why this might be important, so I'll just take a moment here and just simply observe the obvious, and that is that all of us who own and operate mainframes with CICS-based applications, we are living in a hybrid IT world. I don't think I could find an organization today who has a mainframe, CICS, only CICS, and nothing but CICS. Everyone is living in a hybrid world. But the key thing to remember is that not all distributed apps that are interacting with your mainframe are good citizens, and we'll show you some examples of that. In fact, there are some exceedingly bad citizens out there. And it's important for you to be able to see those and determine what you should do about it. So again, with integration analytics, we want to let you identify either some of those bad citizens, so to speak, the offenders, and then to be able to decide upon optimization or remediation strategies, and then perhaps move into a whole different style of integration that's more resilient and performant. I'm going to tick through 3 case studies very quickly. We're not going to go into a lot of detail on them, but these are actual customers that we've worked with. This happens to be in a large organization that is in the one of their lines of business is auto insurance. They have a third-party core CICS business application related to their business, their insurance business. Obviously, one of the most routine business processes might be adding a vehicle to a policy, but they noticed that that was spawning a lot of mainframe activity. And that activity was, first of all, kind of hard to figure out what exactly the user was doing and how it correlated to the activity on the mainframe. And then it was also kind of hard to forecast when were they really going to need more cycles? Because they just didn't have enough insight as to what was really going on. So we were able to, using some tools that we'll talk about later, be able to look at a couple of things. For example, we were able to connect all the dots and be able to understand that adding one vehicle to a policy spawned a myriad of activities that ultimately ended up in about 14,000 CICS TCB switches, which triggered about 28 million unnecessary instructions. Not only that, we were able to look under the covers and see that whenever that new vehicle addition process was being run under CICS, there were a whole lot of start activities that probably should have been link activities. And so with this information, this customer was able to go back to the ISV and to request a change to the application that is starting to yield benefits even today. Case number 2 is a public sector customer. They were very aware of some unexplained spikes in CICS workload and transaction processing costs. And we're going to look at this in a minute in a little more detail. But clearly, these unexplained spikes were representing a processing cost, but also a performance bottleneck, and really prevented other workload from being processed on a timely basis. What integration analytics revealed is that this particular customer was using an approach where they were using a distributed application running on a server. Let's assume it's a Java-based application or a .NET application. It was sending requests, high volumes of requests into the mainframe, each one running a single CICS transaction. And the integration analytics both reveals it, it outlines the cost of that, and then clearly a more effective design pattern is using a one-to-many approach where one request goes in. All of the detailed CICS transaction interactions are handled at memory-to-memory speed, and then a single response goes back. We'll actually look a little bit more at this particular case study in a moment. Then a third one was a very large global technology supply chain company. And literally our journey with them started by someone with the company calling me and saying, hey, I don't know if we need one of your products or not, but I sure would like to buy a few hours of your time to come look under the covers and help us understand why our mainframe transaction volume always seems to grow asymmetrically compared to our business volume. Our business volume is growing nicely, 5, 10, 15, maybe even 20% compounded year over year, but our mainframe transaction volume just eclipses that. And so we were able to, using our integration analytics capabilities, be able to go in there and look and see that the reality, that their problem, the reality was that they had a lot of technology. Again, they're a global company. They have had a decade, almost 2 decades of end user departments and organizations acquiring various types of technology and using that technology to create their own approaches to automating mainframe interaction. One such approach is they have a lot of Excel macros. They use terminal emulation and screen scraping to interact with the mainframe. Thousands of interactions from individual spreadsheets. Then they also utilize a formal RPA platform. I believe, well, I don't want to mention which one, but that RPA platform then somewhat institutionalizes this whole approach of running hundreds or tens of thousands of transactions against the mainframe in order to perform a particular business operation. It's no wonder that, and it should be no surprise, that efficiency is poor, latency is through the roof, and the cost of this overall approach is very high. So what we're able to recommend through the basis of integration analytics is particularly to be able to help them see how they could we could optimize the way their RPA platform was interacting with the mainframe, so that the RPA platform is making just one CICS API call to the mainframe then doing the work under the covers and then sending back a single response. Efficiency went up, latency went down, and the overall cost footprint went down as well. Before I get to some sample dashboards, let me just tell you how we enable this. As with, it's probably no surprise that the foundation of doing analytics work like this might be SMF 110 records. And in fact, that's what we use as the foundation. And then we have written a component called, we call it HTAC, for HTAC, HostBridge Transaction Analytics Connector. And what this software product does is it runs inside of CICS. It leverages a component of CICS called transaction tracking. Transaction tracking began kind of being built out in the late transaction server version 4 timeframe, and now in the version 5 timeframe, it's really come into its own. But it really represents infrastructure waiting to be exploited. And so we decided to exploit it. And so what we do with HTAC is we will extract bits of data or metadata from inbound requests, whether they're coming in from HTTP, CTG, MQ, however they come through, and be able to extract a bit of data, and then we populate the CICS transaction tracking origin data. Now that, I put that in quotes there because the origin data is one particular component of information that transaction tracking will carry along. So we populate the origin data with information about where the request came from, and then that origin data finds its way into the SMF 110 data, and then we're able to analyze not just the performance of the transaction, but we're able to see the performance of the transaction in its context. In other words, the context in which it was actually invoked. And then we deliver a set of dashboards to perform this analysis via Splunk. Now, I just want to mention that for a minute. Right now, the dashboards that we deliver are tied to the use of Splunk. Now, if you're not familiar with Splunk, it's one of the most common platforms for IT operations analytics on the planet. They are kind of the 600-pound gorilla in that space. We did a survey of our customers a few years ago, and we found that virtually 100% of our large corporate customers had Splunk. However, they might not be currently using it for their mainframe. So if you're not sure you have Splunk, what I'd say is the odds are you do, that is the platform that we deliver our dashboards on. If not, it's easy to get a free Splunk trial license to be able to kick the tires. And we are a Splunk partner. So let's actually get down to some fun stuff, and let's look at some dashboards. These dashboards actually came off live data. And this one, for example, is just one of the first things that we do. We do an analysis of think time. We want to be able to see, the kind of the inter-transaction think time, because it's one of the first and most obvious giveaways as to there possibly being some sort of robotic process or automated activity that's driving mainframe transaction volume. This particular slice of data was a 2-hour slice incorporating about 250,000 transactions. And we were able to, from this, stitch together that there were probably around 38,000 RPA sequences that occurred. And using a think time factor of half a second, we were able to determine that the lion's share of all activity hitting this particular region probably was actually being driven by an RPA source as opposed to a human operator actually moderating the flow of transaction requests coming in. But once we have this data and we're able to stitch together what we call these robotic process automation chains of activity, then we can actually start looking at it more detailed. So for example, and what I'm going to do on this slide is I'm going to expand it because I want you to see the highlighted area. This is an example of our DNA analysis, where by DNA we mean if there is a program, a distributed system outside the mainframe, and it is automating something in terms of CICS transactions, we want to be able to see what transactions it's actually running. And we want to be able, so that, well, we want to make sure that there's enough visibility so that a subject matter expert who knows the application can kind of have an aha moment and say, oh, I see what they're doing. So in this case, in this particular interval of time, the heaviest RPA we were able to detect was one that lasted 599 seconds or 10 minutes. It came from a logical unit name of term 2387. The RPA over that 10 minutes of time ran 6,746 transactions. It chewed up 14 seconds of CPU time, and this is a big modern mainframe system. That's a lot of time. And what it did, in the RPA stats, you can see the transactions that it ran and the number it ran sorted by alphabetical order. And then in the RPA DNA column, it shows us the actual sequence that occurred. So this robotic process activity, and I can't remember, this may have actually been driven by a spreadsheet. I'm not sure if it's a spreadsheet or an RPA bot, but it hit the menu transaction one time, and then it camped out on the CTLG transaction, ran it 6,745 times as it was screen scraping data off the screen. Now, when our customer, the person who owns and operates, who owns the application and operates CICS and their mainframe infrastructure saw this, of course, their jaws sort of hit the table, because this sort of visibility, this contextual visibility, is just not something they had ever had. And so they were able to very easily deduce that what had happened here is that an individual, not just an individual, but a group within the organization had written an Excel spreadsheet to screen scrape a set of transactions. And this was originally done maybe a decade ago in order to help those people, those individuals, do their job more efficiently. I mean, there's always a good reason at some point in time why these sorts of things were written. It's just there's frequently not a good reason to continue doing it a decade later. And in fact, in this case, this same information that was being screen scraped by running 6,700 transactions was available in a PDF report that they generated every night. But word of that PDF report had never gotten to the end users, and they were so accustomed to doing their job a certain way that they continued to run this particular spreadsheet driving these transactions. So again, the idea is we want to be able to reveal the DNA of these activities to the point to where a subject matter expert can look at it and go, oh, I know what they're doing, and then make necessary steps. The second one we're highlighting, where they went from the order transaction to the menu transaction, and then over to what we think was a pricing transaction. This was actually repricing orders in their system. And it turned out there was no more efficient way to do this. And so they looked at that and they said, well, this is clearly something they need to do. So that should be turned into a far more efficient process. And so that second one there, where they use the order transaction, the pricing transaction, now that information that users are doing this has now been used to define a business requirement that there needs to be a far more efficient way to reprice pending orders than running 4,300 transactions consuming 15 seconds of CPU time. So that's an example or a taste of the kinds of things we're wanting to show organizations. These are a couple of other examples that I just pulled off our in-house Splunk system to let you see some of the things that we see. This first little screenshot shows a sequence of activities, and these aren't notable by their size. These are notable by they're notable by their size in that they're very small. We noted thousands of these sorts of sequences where a distributed system runs a transaction and presses the enter key. They then press the clear key, which is proper. They then press PF9, which gets them to a menu, and then they press the enter key and they stop. Now, so we went back to them and said, what functional benefit does that have? And they go, the application people said, well, nothing. There's nothing productive that can happen by running that sequence of activities. Well, we chased it all the way back to the server side, and it turns out that someone had written a process that for whatever reason, they run that sequence, so they call a subroutine that does those 4 steps just to determine if the mainframe is up. So they establish a connection, run the transaction, go through a couple of menus, they satisfies their curiosity, and then they disconnect. Well, this is happening thousands of times. During the benchmark interval I looked at, which was 2 hours, we saw it happening at least, I'd say, 10 to 15,000 times. So just imagine the amount of time and energy that's being spent. Also, notice the CPU time. And I'll tell you a story about this. We began to particularly notice that some of these transaction interactions were having an absurd amount of CPU consumption. 34,000 microseconds on a modern mainframe is a lot of time. And so we were able to dig under the covers to see what was going on. And it turned out that that CPU consumption was tied directly to the customer's choice or decision about 1.5 years ago to change their RACF password management scheme under the covers from, instead of using the so-called legacy pattern, to now using what's called KDF AES. And if you and your organization have opted to use KDF AES for RACF password management, then you really need to make sure that you have any and all CICS maintenance applied, because the amount of CPU time if you don't, the amount of CPU time that is consumed between CICS and RACF doing user authentication after you opt for KDF AES goes much higher. So we were able to actually see that operational impact here. The bottom one I included in the presentation just to let you know that there are obviously things that happen that none of us can imagine why they would happen. And here's a good example. Someone has written a process that runs on a server. And what this process does is it logs on to CICS, it transitions through a couple of screens, and then it proceeds to press the enter key 200 times. And then it terminates the session. So on this screen where you see down here where it says enter *200, that's our symbology in our DNA presentation, so you know what they've done. So literally, they began a session, they ran the F400 transaction, pressed clear. That little pound sign after the clear means that was the leg in this whole chain that took the maximum user CPU time of 37,000 microseconds. They then pressed the PF9 key to get back to a menu screen, and on that menu screen, they pressed the enter key 200 times, and then they deleted. Now, we're now trying to ask, so we're gently suggesting to the customer that they probably ought to chase this back to the server and figure out if there's really a business reason to press the enter key 200 times on what appears to be a menu screen. So again, these are some of the interesting things that we see when we actually get some of this SMF 110 data. Whether or not we augment it with the HTAC data or not, we always learn something. So let me wrap up before maybe we do a little Q&A. And that is, so do you need integration analytics? And I would say, yes, you do. It's worth your time to do this. If you are seeing some unexplained spikes in workload, if you have limited visibility as to what's really driving your CICS transaction volume, if you're hoping to identify inefficient applications, or particularly if you have high or unexplained volumes for screen-based transactions or applications, that's a dead giveaway. Also, frankly, if it's just been a long time since you've looked under the covers to see how the distributed world is driving your transaction volume, it's always insightful. Because getting a kind of a more complete end-to-end view of how your hybrid apps are driving CICS is always valuable. There are a couple of easy ways to dip your toe into this water. The first thing is that we'd offer to anyone in the CICS virtual users group, if you would like to send us some SMF 110 data, and we're happy to sign a non-disclosure agreement if you so desire. We've done this with many customers. You can send us an hour or 2 hours of SMF 110 data, and we will literally load that into our analytics platform. And then we will schedule a WebEx meeting or a Zoom meeting with you to show you your data on using this sort of a dashboarding approach and see what we can find. There's also what we call an on-site option. If you have Splunk, we're more than happy to send HTAC to you for installation in a test environment or on a demo basis on your system. And then if you have Splunk, then you can load the data directly into your Splunk instance, and then we'll provide whatever remote support or as required, or perform the analysis using our dashboards. And then, of course, regardless of how you might choose to begin your journey in this area of integration analytics, it'd be our privilege and pleasure to work with you to help you perform this analysis, come up with suggestions for what it means and interpret it, to be able to create dashboards that are purpose-built for your organization, and perhaps be able to achieve more optimization in the way the outside world is interacting with CICS. Let me wrap up by saying that we just introduced 3 new white papers, and these are very specific to RPA, or robotic process automation. There are the 3 most prominent RPA platforms today, and certainly within our customers, are Automation Anywhere, Blue Prism, and UiPath. And so we have written a specific white paper for each one, illustrating how these RPA platforms interact with the mainframe by default, and to be quite honest, what that's really going to mean and how that's going to impact the mainframe. by default, all three of these products, if they are to interact with a mainframe transactions, they will typically do it through terminal emulation and screen scraping. And nothing can be more brittle or perform poorly as high volume integration using terminal emulation and screen scraping. So we've written these 3 white papers specifically for organizations who use those products and explain to them how there's a far better way to have your RPA platform integrate to the mainframe than terminal emulation and screen scraping. With that, let me just say, there are always ways to learn more. First of all, feel free to reach out to me. I'm accessible certainly by email. My phone number is there. Notwithstanding the fact that we're all working from home, we are in heavy interaction with customers day in and day out around these topics. So we'd love to interact with you. There's a website link where you can go and get some of those white papers and other resources. And beyond that, I think I will catch my breath, grab a drink of water, and Trevor, if there are any questions, I'd be happy to answer them, or just let you proceed with the remainder of the virtual CICS users group.
Okay, thanks, Russ. That was great. I mean, if anyone does have any questions, if you type them into the chat, then I'll read them out and we get Russ to answer them now. So I'll just give people a minute or two to do some typing and give you a chance to have a little sip of your drink.
I have found the water bottle.
Oh, good. Well, yeah, it doesn't look like anyone's desperate to win a mug.
Okay, well.
People normally like mugs.
Well, it's not a problem. We understand the reluctance about asking questions in an open forum like this, but again, I'd encourage you, just pick up the phone and call us or send us an email. We'd be happy to engage. And again, our offer always stands. If you'd like to see an analysis of your of one of your CICS regions, kind of put under the microscope of our analytics tools, just let us know. We would love to take a small slice of SMF 110s and then provide back to you a free analysis of what we found. With that, Trevor, thank you very much.
All right, thank you. If anyone does have any questions, then Russ's email address is on screen. Mine will be on screen later, so if you send it to either of us, it'll get an answer from HostBridge. So, yes, as we're a virtual user group, then Russ, I'd like you to assume that you're getting a virtual round of applause at the moment.
Thank you very much.
Okay, let me share my screen. Oh, yeah. Let's go down. Right, yes, thank you very much for that. And right, so moving on then to news, and this is a surprising news announcement considering we're a CICS group. Microsoft has announced Host Integration Server 2020. And that allows organizations to use Microsoft services and products to connect to IBM tools such as CICS 5.4, SOS 2.3, and some other bits and pieces using the industry standard high performance routing, or HPR, and TCP/IP. And the idea is that this reduces, so they say, operating expenses and total cost of ownership while supporting existing and new computing workloads. There's a link to that story on our website. As for articles then, There's improved operation and maintenance with IBM Z Common Data Provider. And that's by Yanzi Song, Al Ping Fen, and Yanang Tian. And that was published in IBM Systems magazine at the very end of June. And again, there's a link to that article on our website, which, just to remind you, is virtualkics.hostbridge.com/articles.htm. Yep, feedback request there is to ask you for feedback, anything good, anything you think we can improve on for next time. And my email address is on screen there. You can send your comments to me. We also have a Contact Us webpage, and you can use that to talk to me. So, as you can see, planned for the future. Our next meeting is on the 8th of September, when we have Colin Pierce, and he'll be discussing debugging CICS COBOL Azure Abends with Enterprise COBOL 6.2. And the meeting after that is on the 3rd of November, when we have Ezreal Gross, who's Principal Solutions Advisor with Rocket Software. He'll be speaking, and we'll publish the title of that presentation slightly nearer the time. Just a reminder that you can keep up to date with what's happening in the world of CICS and on the Virtual CICS User Group website by following us on Facebook and Twitter, or by joining the Virtual CICS group on LinkedIn. And the URLs for all of those are on screen at the moment, but they're also on the homepage of our website. And of course, in the days of social media, everyone likes likes. So if you can like us on Facebook, that would be great. And if you tweet or Instagram or any of those, the hashtag to use is hashtag #VirtualCICS. Okay, that's all for this meeting of the Virtual CICS User Group. Can I thank you all for attending? And thanks to HostBridge Technology for sponsoring our user group and making this possible. And of course, I'd particularly like to thank Russ Teubner for his presentation today. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you again on the 8th of September. So thank you and goodbye.